In our last episode, I shared some concepts about Bluetooth Low Energy, the ones that are required in order to implement a Bluetooth Low Energy peripheral. We use a Raspberry Pi Pico in order to implement those concepts, and we ended up with a prototype firmware that was able to use the LED, the onboard LED. We also have the ability to read from the onboard temperature sensor, and we offer two Bluetooth Low Energy services as a Bluetooth Low Energy peripheral. There were also several characteristics, and one of them depended on the temperature. And it could be read, and you could request notifications from another device. You can find that in the previous video, or also you can use this QR code and this link in order to access information and resources for the previous and other episodes, including the code repository for the firmware. My original plan for this episode was to write the other side of the communication, of the Bluetooth Low Energy communication. So I was planning to write a Bluetooth Low Energy central in order to gather information from the sensors that were talking Bluetooth Low Energy. I was going to implement that for a Raspberry Pi OS that is running in a Raspberry Pi that I have here with me. But I realized that in order to talk to the Raspberry Pi Bluetooth stack, it is required to use the DBus API. And DBus has its own complexity. So I decided to split this into two episodes. The first one, this one, I'm going to talk about DBus and how to interact with DBus from the command line and also from messages in order to talk to Bluetooth and do what we did from the application in the mobile phone in the previous episode. And the second one, I will be writing the C++ code in order to talk to the DBus Bluetooth implementation. Different platforms use different ways to interact with Bluetooth when it is available. You could use different libraries, different APIs. In the case of Linux, Bluez became the official Bluetooth stack in 2004. And it replaced the previously available OpenBT that was used until then. At the beginning, everything was command-based. So all the utilities were command line utilities, and you use them in order to connect two devices, to pair, to do anything. But since the beginning, there was some demand for integrating Bluetooth into the desktop environments. Since Bluez at the beginning was using raw sockets and these command line interfaces, that was not very suitable, so a different approach had to be searched and adopted in order to share this Bluetooth capability among the different applications on the desktop. So they decided to use a daemon that was taking care of all the things that were happening outside of the kernel, and then an API that allowed to share access to this daemon. At the time, DBus had already been designed and implemented and adopted by major desktops, and it was chosen as the obvious selection for having this API shared. So DBus acts as the entry gate for accessing the Bluez services. DBus, which stands for Desktop Bus, is an inter-process communication mechanism. It uses a message bus, and it is responsible for taking the messages that the applications connected to the bus send and deliver them to other applications that are also connected to the bus. There are two types of buses. One is the system bus, and it is used to access system components like systemd or the Bluetooth stack that we are going to try to address here. The second type of buses is the session bus, and there is one session bus for each of the users that are logged into the system. In order to use Bluetooth, our application will have to interact with DBus, with the Bluetooth service that has been connected to DBus. Services get connected by registering to the DBus. DBus keeps an inventory of all the services that have connected to it. And for each one of these pieces of functionality, all these services, it has a representation which is an object, in the sense of object-oriented programming. Each of these objects implements one or more interfaces, and those interfaces have a name that is a string in the form of a reverse DNS. The interfaces have properties, methods, and signals. A property is a value that one can get or set. A method is a piece of functionality of that object that can be invoked and using some parameters and getting some return values or not. And finally, you have signals which are events. They are information that the object emits without any external trigger. When we connect to DBus as a client, we get a unique connection identifier. That is a unique identifier for our connection with the DBus. When objects are exposed to the DBus, when they are registered, they also get its own unique identifier. But that unique identifier is encoded as a path. That path can be used to route messages and to deliver them. Applications can use those objects to send them messages, read from their properties, and also to subscribe to their signals. Linux, among other operating systems, implements a very thin layer that allows the host to communicate with the Bluetooth stack hardware. That interface is called the Host Controller Interface, or HCI. In the past, HCI config and HCI tool were the Bluez tools that were used in order to interact with the Bluetooth stack. But those tools were using raw sockets, and as we mentioned before, this is not the best option if you want to share connection data among different applications on the desktop. Nowadays, people are using Bluetooth CTL and BT MGMT, which use DBus underneath, and are the ones that we are going to use in our following example. We can now work with our Bluetooth device, and the first thing would be to switch it on. Let's use Bluetooth CTL. In the past, we would have used HCI config HCI 0 app, but in this case, we are going to use Bluetooth CTL. And when we enter into the command line, the tool, we get a prompt. In the prompt, we will be able to use different commands for that. And the first one that we are going to use is show. Show is giving us information about the device, and among other things is showing us that this device is not powered up yet. So let's do that. Let's power on the device, and it changes the status of this property. It says so, but we want to verify it using show again to see that everything went fine. So yes, we got power yes here. Okay, now that we have the Bluetooth radio enabled, we can go and use the device to scan other devices that I have around. Particularly, we are looking for our BLE peripheral. So let's go to the scan menu, and let me remind you that our Bluetooth low energy peripheral is a LE low energy device. So we need to set the transport to low energy, and then we can go back in the menu, and then we can use the scanning capabilities of the Bluetooth device in order to find devices that I have around. As you can see, I already have found the RP2 sensor that I have here. I can even use the devices command here, and it will show me the ones that it has found so far. And I can connect to it. So I can use this in order to connect to the device. And let me stop the scanning and go back with the scroll to the message that it showed when it connected to it. So I ask for a connection to the device. It says that the connection is successful. And now it starts showing me the services and the characteristics. So this is a generic attribute profile. And the characteristic that it shows me is whether the service changed or not. Oh, sorry. Let me go a little bit here. After that, I have another service, which is the device information, the first one that we implemented in our Raspberry Pi Pico. And it has all the characteristics that we were interested in providing, that were the manufacturer name, the model number, also a serial number here, the firmware revision, and even the hardware revision, and that's it. Okay, it has the environmental sensing service. That was the one that we were using to share the temperature. And it has a characteristic inside of that service that is this temperature measurement that we were using to share the onboard temperature sensor. And it even has information about the descriptors that the device has and for this characteristic. So it has the client characteristic configuration for enabling notifications and deciding how the environmental sensing trigger setting is configured. And then you can have here the logic for deciding when notifications are sent. Okay, so that's it. We have all the information about the device, but obviously you cannot be watching at that information all the time. So once you have scanned off, you can go and use this GAT, this General Attribute Profile menu, and here you have new comments. The command that we are going to use is to list the attributes, which is going to provide us with the same information that we saw before when we connected to the device. But usually you connect to the device and you want to figure out how to obtain information from it. Then you go to a characteristic, then you want to check what other characteristics were available. And that's why you need this command to be available for you and to provide you with the information that this device is offering to you. Okay, the next thing that we would like to do is to use this characteristic that was the temperature measurement. And in order to do that, I'm going to select the attribute that uses this path. Let me remind you that when we talk about the characteristic, in the case of DBus, it is bound to a path, a unique ID for each of the things that were offered. So I'm going to connect to this one and I'm going to read from it. And it provides me the information from this characteristic. So I have the 5 bytes that, if you remember, I was writing in the firmware implementation of the last episode. The first one is the 00, which means that I don't have a data stamp and I don't use Fahrenheit, but rather I use Celsius. The first 3 bytes here are the temperature encoded multiplied by the precision, which is here, which is a -2. So this, I'm not going to do the effort, but basically if you multiplied f by 16 twice and then add 8 by 16, you will have a number that when divided by 100, it will be the temperature. The other thing that you can do is
accept notifications. You can request them and get them. So we are going to do that. We are going to enable notifications, and then we will start listening to those notifications that it will take some time, and it was sending the notifications every 15 seconds. That was the only rule that we set for the notifications. And as you can see here, it's giving me the value, and probably if I use, I have touched the sensor to modify slightly the temperature, and it changes with the notification. Okay, so I stop the notifications, and the only thing that is left to do here is basically disconnecting from our BLE peripheral. So I'm going to go back from the GAT menu, and I'm going to disconnect from the device, and I'm going to power off the Bluetooth radio. And that's basically it.
Now that we understand the sequence of things that have to happen in order to talk to our BLE peripheral, we are going to try to reproduce the same sequence using DBus messages directly.
We're going to use DBus-send, which is a tool that comes with DBus itself. The thing that we're going to do first is to use the tool in order to send a message to the destination or.freedesktop.dbus. We are going to send it to the only instance of this object, and we're going to use this interface, which is the or.freedesktop.dbus introspectable, and the method that we plan to use is introspect, that, as the name says, is something like inception, that we are going to ask it what it allows us to do. And we're going to send this message through the system bus, and we're going to request to print the response. I'm finally piping it to less so we can read it, because it's going to be a long response. So this is what we get. We get a node that contains all this data. The data is basically interfaces that the object implements, and the first interface that it has is this one, which is the basic one that is required in order to establish connections with the DBus. The hello method is the method that allows you to establish a connection, and then there are other methods here to request a name for a connection, the connection unique name, and release it, and start a service, and so on. Notice that the methods come with some additional data, like the arguments that the method requires. So, for example, here I have 3 things, 2 of which are arguments, and I know that because it says in and in. Well, this is the return value because it says out. It also provides information about the type, so you have a string here and an unsigned number here. Okay? Same thing for the return, which is also an unsigned. So this is the information for the method. But let me remind you that an interface has 3 bits of information. One is the methods, the other one are properties, and the third one are signals. So let's go a little bit down here in the information, and we can see that after all these methods, we have a couple of properties here. This first property is called features, and it has a type of an array of strings here, and it can be only read. If it changes, it has this annotation telling us that in case it changes, it will send a signal with the data about the property having been changed. And this is the type of signals that this object emits. The name owner change, for example, is one of them, and it comes with 3 strings as values in the signal. There are other things here like name lost, name acquired. So This is the end of the interface, and you can see that the same object implements other interfaces. So this other interface, the second one, is meant to be able to work with properties. First one was to be able to connect and disconnect from the DBus. Second one is to interact with the properties. So for example, here I have the get method that allows me to get the value of a property. I need two arguments, not just one, because it's not just the name of the property, but the interface to which the property belongs to and the name of the property, two strings. And I have the value here that is returned as a variant that we will mention later. There are more interfaces in the same object. So we have the introspectable one, which we already know because this is the one that we have used in order to query for the capabilities of this object. And then we have the monitoring one, the state one, the stats one, and the peer one. And this is it. This is basically what we have here for the main object of the DBus environment. Now that we know that, we can use some one of these methods in order to get more information about what we have in the DBus. We would like to know the names of the things that are connected. So we are going to use one of the methods that we have there in the org.freedesktop.dbus interface, which is listNames. And when we invoke it, we have a list, an array of strings that represents each of the things that are connected here to the DBus. Notice that in my it says that the destination, which is my connection of the DBus send, is 1.65. That's me because I'm receiving this information. And if I query it again, same thing, I will get 1.66. So the connection is created for DBus send, and then it is closed after the response is printed. And here I have several things that are connected to DBus, and one of them is the one that we would like to interact with, which is org.bluez. Okay, so looks good. Let's now try to interact with this org.bluez. And we're going to create another message here that is going to use org.bluez as the destination, the only instance of it, and we're going to introspect this object in order to get information about what is able to do. In this case, I'm using also XML lint in order to prettify the information. You can use other tools if you prefer, but this one is good enough for me and is doing the formatting of the XML in a way that we can read it much easier than what it usually creates. So here I have the response from the Bluez service, and the first interface that it shows is introspectable. We already know about this one. Then we have like the agent manager here, which allows me to register or unregister an agent. Then we have the profile manager, and we have health manager. And well, this is basically how a Bluetooth interface works, but notice that the important bit of information is here. It tells me that there is one actual hardware interface, which is the HCI 0 for host controller interface instance 0. That is the one that is going to be working for me. So let's try to query that one. And in order to do so, I am going to first figure out how the hierarchy of these interfaces work, these objects. And as you can see here, I have the dash org, the path that I was showing before, the slash org slash bluez, which was the object that I was talking to, and then this node that I have here. I'm going to send it a message, and the message is going to be the introspect method that I was using before. So I'm using the same parameters, but in this case, the instance I'm talking to is not just Bluez, but HCI 0. So let's go and do that. And you can see now that besides the introspectable interface, and that was also present before, I have new things here. I have information about the adapter and methods here that sound familiar, like start discovery, set discovery filter, stop discovery. So that seems like the scanning thing that the Bluetooth is usually doing when we request it to do so. And then we have some other interfaces here that are first, before the interfaces, let me talk about the properties that we have here. We have properties that were the ones that were printed with Bluetooth CTL when we use the show command. And one of them, the one that we were looking for before, was the powered one. So we were checking whether the radio was powered on or off. And then we have this other, the properties interfaces, the interface that we use, as we mentioned before, to set or get properties. But we have more stuff here. We have the general attribute profile manager, that is the one that is going to allow us to interact with other devices. And we even have some things here to do the low energy advertisement. So in order to announce ourselves as provider of a BLE peripheral. We also have things that we didn't mention before, like the media capabilities of Bluetooth and some other stuff that is not relevant for this use case, okay? So now that we have figured out how to talk to our Bluetooth hardware, let's do so. Let's try to power the interface using the property. So we are going to first query the value to verify that it is not powered on. And in order to do so, I use the instance of this host control interface that I was mentioning before. I'm going to use now the other interface, that is the one that is required to interact with properties, or .freedesktop.dbus.properties. And in this case, I'm going to use the get method because I'm going to read the property. As I mentioned before, we need two parameters, one for the interface name and one for the property name, because the same property can be in different interfaces. So I run this one and I get the response, which is a variant. A variant is telling me that the thing that it returns can be of a different type depending on the property. In this case, for this property, the value is a Boolean. So it returns something that must be encoded, and then you have to know what the type is and then also what the value is. So in this case, we get to know that this property, the radio enabled thing, the power property of the device, is off. So let's try to change that value, and we do that by sending another message, but in this case using the set method instead of the get method. Same thing, in this case we have three parameters. One is for the interface, second one for the name of the property, third one for the value. And we use the same encoding here. We say this is a variant which contains a Boolean that is true. So we send this and we are going to query it again and verify that, yeah, now the value is true. So the radio is enabled. Cool. So what else could we do? Well, we could do many things, but the most obvious one is to scan for devices. And do you remember that we found some services there, some methods that were available for us, and one of them was to start the discovery. So let's try to run this one and be totally deceived because, well, we didn't get any results. It has sent a message, it has invoked the method, but we didn't get any responses from that. And why is that the case? Well, do you remember what we did when I was listing the names of the things that were connected to DBus, and I mentioned that DBus was creating a connection for each invocation of the DBus send, and it was closing it right afterwards. So the problem here is that DBus is paying attention to the request for discovery. And if the thing that was requesting for the discovery disconnects from DBus, it stops the discovery. So that is not going to work for us. What we could do instead is to try to do some reverse engineering to understand the messages rather than sending them. So we're going to have here a second panel, and we're going to run in this other panel sorry, not this one, to run in this other panel the DBus monitor. This is going to be reading every message that goes through the system bus. And I'm going to save these messages, to store them in this file and put it in the background. And I'm going to use less in order to be updating the contents of this file and understand the messages that are being sent every time. So let's start here, and this is what has been done in order to run the DBus monitor itself. And there's nothing else here. Now I can go to the other screen and then run Bluetooth CTL, the tool that I was using before. I connect to Bluetooth CTL, and if I go back to the other window and I refresh the contents, you will see that a new connection has been done with Bluetooth CTL, with the Bluez from Bluetooth CTL, and that is a connection that is not closed. This 1.75 is what has been created here, and it is talking to Bluez in order to work with it. So that's perfectly fine, and this is where it says that it's talking to Bluez. And well, now that we have this, we are going to go to the end and try to reproduce the sequence of commands that we had before. Okay, so let's go to the other pane, and here we're going to use the menu scan, and I'm going to use the transport low energy as we did before, and I'm going back. Let me go to the other window, refresh, and notice that there's no new message. Why? Because this is just configuration in the Bluetooth CTL tool. There is no message that is exchanged with DBus yet. Let's go to the Bluetooth CTL window, and here I'm going to invoke now the scan on. I'm going to connect, and I'm going to close the scanning. So I'm scanning, I'm checking the devices, connecting, and scanning off. Same sequence that I did before. So notice that the information about the descriptors and the characteristics are here. So it has worked. I am connected to the RP2 sensor here, and I'm going to check the other window for the messages that have been exchanged with the DBus server. So let's go to the other window, and here I'm going to refresh, and let's go step by step here. So the first thing that has been done is this set discovery filter, and this is only meant to choose the transport to be low energy. We set that in the options, but it doesn't send any message until we start scanning. Okay, the next thing is obvious, which is let's start scanning now. So start discovery, and after that we start getting information about what has changed. The first thing that has changed is that now our device is discovering, so the status of this property has changed itself. But also we get signals from each and every one of the devices that are available around me. So I get this and a description of what they have inside, some of its properties, if it is blocked, trusted, and so on. So all of the information that we can have here that would be about all these properties. Not just for one device, but for all of them. So I'm getting a few here, and let me show you another message that is relevant. Here, I see that there is a message that is sent to the method addMatch. And that is because from this point on, while I'm scanning these for devices, I have detected this one, so I'm interested in information that this device is still sending. So I add this match in order to get information from this device. And let me continue here. It gets information from other devices. And one of the things that we should be noticing is, let me see if that is, okay. Here, I notice that some interfaces have been added, and that is because I'm still able to talk to all these devices. But if I now check for connected, this is the property for one of the devices. I'm not looking for this one. I'm going to hopefully find a very different one. These are all the devices. I'm moving through them. And here I get the connect request. This is the method that is sent to connect to these devices. And then here I get information about the device itself, and I have all this query for the information. I do the exchange, I get the properties from the device, and in the end, hopefully, let me try to move forward a little bit. Here I get an update saying, now we are connected, okay? And you also can find in this file, probably before you get the update, some messages that are regarding the remove match that, remove match. And these are the messages that are required in order to say, I don't care about these other interfaces any longer. So please disregard messages coming from them. So that's basically it. And we have been able to scan and connect using these messages that I was mentioning. Sorry, let me connect back to the log file. And let's continue from here, because it is not enough to do the connection. We want to read from it. So how do we do that? Well, let me remind you that the way we were doing that was by going to the GAT menu and selecting, well, first listing the attributes that we had there. And let me go to the other window and verify that no new message has been sent. So this data is being cached in the Bluetooth CTL tool, and no message is exchanged in order to obtain the list of attributes again. And the next thing that I want to do is select the attribute that I'm interested in. And the same thing, if I go to the other window and I update, there's nothing happening there. But when I do the actual read, then I can go and see if this has been updated. And indeed, there is a message here that has information, this read value, that receives the information from the device itself. So it requests the data offset 0 from the device, and it receives the response, it receives the response that is printed here, okay? Same thing happens. Let me go to the end. Yeah, here. If I turn notification on, receive a notification. Let me remind you that we have to wait for something around 15 seconds. And in the end, we will have the value here, and we will have the notification off here. So if we go to the other window up there and we refresh, we will see that we have invoked the start notify method, and we get signals for the things that have changed. And finally, we invoke the, let me go down there here. We invoke the stop notify for that property. And that's basically it. The only thing that I have to do in order to go back to reproduce the whole example that we were using before is to go to the other window and continue with the disconnection, which is disconnect and power off. And here I will also have messages saying that. So if I refresh here, I get the disconnect message, and I will have the property change, the request for the property change for being connected. And that's it, and also for the power. Okay, so not here, but here. Yep. So that's basically it. That's all I wanted to show you. With all these tools here, we are now able to reproduce the connection to a Bluetooth low energy peripheral using the DBus message.
In this episode, I have explained the sequence of steps that have to be conducted in order to interact with a BLE peripheral device from the command line. Then I have done some reverse engineering in order to understand how each one of those steps would translate into DBus messages. You can find the resources for this episode and links to other episodes in the QR code or URL that you can see now. In the next episode, I will try to use the information that we have gathered about the DBus messages in order to interact with our BLE peripheral using C++. See you there.